Proportions are at the core of yes or no. Proportions are based upon a binary random variable, success or failure, coming from the binomial probability density function. Our preferences are often cast in this same light. Our choices are either A or B. Marketing folks are always looking for that little edge that moves us from one item to another. The goal is to change the proportion of people who buy their stuff. What change would move the proportion at the lowest cost? How did toasting a sandwich make Quiznos gain a higher proportion than Subway? It must have done something, because Subway went out and bought an oven. Preferences are just one place we see proportions. Sometimes it is the result of an experiment where we have success or failure, for example, medical experiments for testing drugs. Because proportions are naturally part of any categorical data, we see many places where they are important for understanding if real differences exist across categories. In short, comparing two proportions, like comparing two means, is common. If two estimated proportions are different, it may be due to a difference in the populations, or it may be due to chance in sampling. A hypothesis test can help determine if a difference in the estimated proportions reflects differences in the population proportions. Like the test for differences in means, the null and alternative hypothesis are written as differences from a particular value, delta. If delta is 0, then we are asking if there is any difference between the two proportions. This is certainly the most usual case. The null and alternative hypotheses are written as H0, P1 minus P2 equal delta naught, versus the alternative, HA, P1 minus P2 does not equal delta naught. Like the case of differences in sample means, we construct a sampling distribution for differences in sample proportions. P1 prime minus P2 prime, where P1 prime is equal to X1 divided by N1, and P2 prime equals X2 divided by N2, where N1 and N2 are the sample sizes taken from the two groups respectively. Again, we go to the central limit theorem to find the distribution of the sampling distribution for the differences in sample proportions. And again, we find that the sampling distribution, like the ones past, are normally distributed as proved by the central limit theorem. This allows us to add the standard normal distribution to our graph. With this information, we can construct a test statistic for the hypotheses that two populations have the same proportion. This test and all others follow the same format. How many standard deviations is the difference in the sample proportions from the hypothesized difference in the population proportions? This is the basic format of the standardizing formula. For this case, the test statistic is provided by this formula, where delta naught is equal to the hypothesized difference between the two proportions. The central limit theorem, besides providing the proof that the sampling distribution is normally distributed, gives us the standard deviation of this distribution. As part of the standard deviation is the idea that all the data should be pooled to give us a consolidated sample proportion, P sub C, which is in this formula. If the null hypothesis is true, then the two populations have the same proportion, and thus the pooled variance is the correct one. This is why it is used in this test statistic. We can use this test to examine a common marketing question concerning the experiment to determine customers' preferences. Amy, a marketing director, conducts an experiment to compare consumer satisfaction with a brand name laundry detergent. The experiment is based on the temperature used for the wash cycle. The first random sample of 500 individuals who agree to participate asked to use the product in the standard size load under a low temperature setting. The second random sample of 500 participants is asked to use the same product on a standard size load under a high temperature setting. 280 participants in the first sample prefer the cleaning outcome of the detergent compared to 320 from the second sample. Is there evidence that the detergent is significantly preferred when used with the high temperature setting than with the low temperature setting? Amy wants to be able to reach her conclusion with 95% confidence. Our first step is to determine if we can even conduct this test. Remember that the foundation distribution is the binomial, and for us to use the normal distribution, we have to ask if both samples come from a distribution that is not too skewed to use the normal distribution. We use the same rule as we did before when testing the hypothesis for a single proportion. Here are the results. We can see that for all 4 cases, they are greater than 5. And this, of course, was the requirement for us to continue. Now we need to set the null and alternative hypothesis. The null represents the world as we see it today, the status quo. This question, as it is asked, presumes a claim that the high temperature would be preferred. The actual statement is whether or not there is evidence that shows, quote, the detergent is significantly preferred when used with a high temperature setting, end quote. All claims go in the alternative hypothesis, and this makes this a one-tailed test. We can see how this affects our graph, which is always helpful in hypothesis tests. The alpha probability is in the left-hand tail and is marked on the z-axis at 1.645 because Amy wants to be 95% confident in her conclusions. Remember, an easy way to find the correct critical value of a normal distribution is to look at the student's t-table at the alpha level desired and go to the infinite degrees of freedom. All we have left is to calculate the test statistic using our formula from a moment ago. We see that the proportion of subjects that prefer the high temperature is greater than the proportion of subjects who prefer the low temperature. 64% versus 56%, 8 percentage points difference. Our question is whether or not this is different enough to be considered statistically significant. How many standard deviations apart are they? The answer is 2.58, and thus the test statistic is in the tail. Amy's conclusion is that she cannot accept the null hypothesis that there is no difference between the preferences of the detergent when the temperature is taken into account. In short, people like it hot.